Hello students, in this video I will go through exercise U5A03B where I will be solving for sides and overlapping right triangles. And you're going to see me apply the formula that we had developed from U5A03A, which was the geometric mean. Okay, so in question number 4 it reads, write a similarity statement identifying the three similar triangles in the figure. So the best way to go about this is to identify the angles that are congruent. So I know that this angle here does not have to be the same as this angle. However, based on concepts of complementary, this angle must be the same as angle E, and this angle over here must be the same as angle D. So with that understanding, I can then draw three different triangles with the same angle markings. Two tick marks, one tick mark, and two tick marks, and one tick mark. Starting with the smallest triangle, I can go EFC, and then to the second, to the middle triangle there, I can go CFD, and then to the largest triangle, I can go ECD. Next, I'm asked to find out what X, Y, and Z is in question 5. I apologize for the grainy image here, but this is X, this is Y, this is Z. So the best way to approach this is to apply the geometric mean. So I know that the geometric mean of 3 and 12 is equal to x squared. So x therefore is equal to 6. And it's 6 because it's 36 is equal to x squared, so the square root of that is equal to 6. Okay, so here, again, apologies for the grainy image here. That's x, that's 8. This is y, and this is z. So, again, x times 8 is equal to 16. It's equal to 16 squared, not equal to 16. So 16 is the same thing as 8 times 2, which is the same thing as 8 squared times 2 squared. So if I divide both sides by 8, I end up with 8 times 2 squared, which is equal to 32. So that's x. X is equal to 32. If x is equal to 32, I can then solve for y and z by using Pythagorean theorem, right? So I know that 32, x is equal to 32. So 32 squared plus 16 squared is equal to y squared. I'm going to add this stuff up. So therefore, y will equal to 32 squared plus 16 squared, 1280. So this is square root of 1280. And this is actually divisible by 16, I believe. Let me see here. Right, that is also divisible by 16. So this turns into 16 radical 5. And to solve for z, okay, I go 8 squared plus 16 squared is equal to z squared, which if I do this, I end up with 64 plus 16 squared is equal to 320. This thing is divisible by 16, which is then divisible by 4. So this is, all in all, this is going to be 8 square root of 5, because square root of 16, square root of 4, that's square root of 8, right? So not square root of 8, it's going to be 8. 8 square root of 5. So z will equal to 8 square root of 5. Okay, moving on. Solving for x, y, and z. So 9 times 4 is equal to x squared, which means x is equal to 6. And I know that 9 squared plus x squared, 6 squared, is equal to y squared. So that's 45 plus 36. That will be 91. So I'm sorry, 81. So y will equal to, y squared will equal to, I'm sorry, I'm not thinking. 9 squared is not 45. 9 squared is 81. So that will be 127. Y squared is 127. And is 127 divisible by anything here? 127 is divisible by 3. No, it's not. Is 127 divisible by 9? No, it won't be because it's not divisible by 3. Right. So I will just leave my answer as 127 then. I just want to make sure that this is right. It's 117, not 127. 117. So y will equal to the square root of 117. Okay, and then z is 6 squared plus 4 squared is equal to z squared, or z will equal to 36 plus 16, and that would be 52. And the square root of 52 is divisible by 4. So it's 2 square root of 13. All right. Next. The overall length is y, so that means this segment there is y minus 6. I apologize again for the grainy image, but this is x and this is z. So y minus 6 times 6 is equal to 17. So therefore, if I distribute, or actually divide by 6, 17 sixths, and then add 6, y will equal to 17 sixths plus 6. And I need to solve for x. So x squared is equal to 6 squared plus 17 squared, or x will equal to the square root of 17 squared plus 36, 325, and that's divisible by 25. So it's 5 squared root of 13. Whenever you can reduce radicals, try and do them, but it's not an absolute must. I always try to. Okay, and then 17 squared plus y squared is equal to z squared. Oh boy. Okay, so 17 squared plus y is equal to 17 6 plus 6, right? So therefore, that will be 36 plus 17 is 53 6. And is that anything? Let's see here. 17 squared plus, or times, 36 plus 53 squared. That's 13,213 over 36. And I want to take the square root of that. 19.158. So z is approximately 19.158. I'm not even going to attempt to reduce the radical just because this question is too crazy. Okay. Moving on. Question 20. Again, I apologize for the grainy image here. So this is x, and then this is z. So I have y squared is equal to 4 times 8. So y is equal to 4 square root of 2, because 4 times 8 is 32. 16 times 2 is 32, so 4 square root of 2. And then y squared plus 4 squared is equal to x squared. So 32 plus 16 is equal to x squared. So x is equal to square root of 48, or 4 square root of 3. 16 times 3 is 48, so 4 square root of 3. And then z, so y squared plus 8 squared is equal to z squared. So 32 plus 64 is equal to 96. So z is equal to square root of 96. And a square root of 96 anything? Let me see here. 96 is divisible by 16. So this is going to be 4 square root of 6. Moving on. Okay. All right, things are getting a little more interesting now. So I know that this length right here is 14 minus y. So 14 minus y times y is equal to x squared. I also know that x squared plus y squared is equal to 5 squared. Right? So what I'm going to do, I have a system of equation here. This is what I'm going to do. I'm going to take these two and I'm going to replace them with one another. So notice that in the first equation, 14 minus y times y is equal to x squared. I'm going to substitute that into the second equation there. So I got 14 minus y times y plus y squared is equal to 5 squared. What I'm going to do is I'm going to distribute. So I get y squared. I get 14y minus y squared plus y squared is equal to 25. Notice the y squares cancel. I'm left with 14y is equal to 25. Or simply y is equal to 25 over 14. Since y is equal to 25 over 14, I can then solve for what x is equal to. Right? So I can then plug this back into either the first equation or the second equation. It looks like maybe the first equation might be, actually no, they're all the same. So what will x turn out to be then? Or actually I'll do it with this guy. X will turn out to be 14 minus 25th. So 14 minus 25 over 14 times 25 over 14. That's equal to x squared. I'm going to take the square root of that. 4.67. So it's approximately 4.67. So x is approximately 4.67. So once I get x is approximately 4.67, I can then solve for what z is. So actually I can solve for z without going through all that. I can do z 5 squared plus z squared is equal to 14 squared. I can solve z without having to go through all that. So z is equal to the square root of 14 squared minus 25 squared. Minus 25. And what is that? So 14 squared minus 25 is 171. So z is equal to the square root of 171. There you go. All right. 22. So I know that 10x is equal to 20 squared. So x is equal to 2 squared times 10 squared divided by 10. Or in other words, x is equal to 40. If x is equal to 40, I can now try to figure out what z is. So I know that 20 squared plus 40 squared is equal to z squared. So that's 400 plus 1600 is equal to z squared. Z is equal to 2000. So 2000 is equal to 2000 square root of 2000. So that would be, what would that be? 2,000 is divisible by, well, it's divisible by 100, so why am I struggling over this? Okay, so z is equal to 10 times square root of 20, which then 20 can be reduced to 2 radical 5. So this is 20 radical 5. There you go. So that's z. And then y is equal to, y squared is equal to 10 squared plus 20 squared. And that would be 100 plus 400. That would be 500. So y will equal to 10 radical 5. Okay. Moving on. So this right here is z. This is x. And this is y. Again, I apologize for the grainy diagram there. So 4z is equal to y squared. I also know that y squared plus z squared is equal to x squared. I know that y squared plus 4 squared is equal to 12 squared. So I can solve for y first. So y squared is equal to 144 minus 16. So y will equal to, what is that? 128, which is divisible by 16. So that will be 128 divided by 16 is 8, which is also divisible by 4. Whoops. So it's 8 square root of 2. And so now that I have y, I can then go back and solve for z, right? So if I have y, which is square root of 128, then 4z, then 4z is equal to 128. Z, therefore, is equal to 32. If z is equal to 32, then I can solve for x. Because y squared is 128. Y squared plus z squared is equal to x squared, right? So 128 plus 32 squared is equal to x squared. So x will equal to, let's see what that is, 32 squared plus 128 is 1152. Square root of 1152. 33.94. So x is approximately 33.94. All right, last couple of problems here. 2 square root of, that is 2 square root of what? 2 square root of 3. So this guy right here is 2 square root of 3. This is square root of 3. And this is x. No, this is z. This is x. And this is y. Okay, so I know, let's see here. I know that z squared plus square root of 3 squared is equal to 2 square root of 3 squared. So z squared plus 3 is equal to 12. Subtract 3, I get 9. So therefore z is equal to 3. Now that I know that z is equal to 3, I can then apply concept. So I know that 2 square root of 3 minus x times x is equal to y squared. I know that x squared plus y squared is equal to z squared. So because of this, okay, I can then substitute what y squared into the second equation. So I can say 2 square root of 3 minus x times x plus x squared is equal to z squared, is equal to 9. If I distribute the x, I'll end up with x squared plus 2 radical 3x minus x squared is equal to 9. The x squares cancel. I'm left with x is equal to 9 over 2 radical 3. And once I have that, I can then figure out what y is. So if that's what x is, then finally y, what will y equal to? So y will equal to the square root of 2 radical 3 minus 9 over 2 radical 3 times 9 over 2 radical 3. And if I punch all of that into the calculator, oh boy, okay. So 2 radical 3 minus 9, whoops. Minus 9 over 2 radical 3. And all of this times 9 divided by 2 radical 3. .25. That was really nice the way that it worked out. 2.25. Oh, and I forgot. I got to take the square root of that, of course. And it comes out even nicer. 1.5. So y is equal to 1.5. Okay. And this guy right here. So x squared, this guy here is x, by the way. This is y, and this is z. So x squared plus, or actually not plus, will equal to 3 radical 2 squared plus radical 2 squared. So x squared will equal to 18 plus 2, which is 20. So x is equal to 2 radical 5. And if x is equal to 2 radical 5, then I can also apply the geometric mean. I can say 3 radical 2 times z is equal to radical 2 squared, or just 2, or z is equal to 2 over 3 radical 2. And I can take that and now solve for y, right? Z squared plus radical 2 squared is equal to y squared. Substitute in what I found for z. So that's 2 over 3 radical 2 squared plus radical 2 squared is just 2. If I square this, I end up with 4 over 18 plus 2 is equal to y squared, or y is equal to 36 plus 4, so it's 40 over 18 square root. And that reduces to 20 over 9, square root of 20 over 9. Which also reduces to 2/3 radical 5. So y is equal to 2/3 radical 5. Okay, moving on, find the values. Notice that it's an S, so we may potentially end up with a multiple values here. So this guy right here is t plus 1, and this is 24. So t plus 1 times 24 is equal to 12. So I'm guessing I have to find out what t is. 24t plus 24 is equal to 12. Subtract both sides by 24, so 24t is equal to negative is equal to negative 12. T is equal to negative half. Okay, sure, why not? Okay, next, sorry again, this is really grainy. I'm guessing this is n plus 4. This is n plus 4. So 24 times 8 is equal to n plus 4 squared. So if that's the case, what's 24 times 8? 192. 192 is equal to n plus 4 squared. I'm going to take the square root of that. And then that's 13.856, right? But it's going to be plus or minus. N will equal to, or n plus 4 will equal to plus or minus square root of 192. Or n will equal to negative 4 plus or minus square root of 192. So can n equal to negative square root of 192, because this is n plus 4 up there, right? And the answer to that is no, it cannot, because you'll end up with a negative altitude and there's no negative length. So n will simply equal to negative 4 plus square root of 192. This is the only answer. Okay. And then the last problem here, m times m plus 5 is equal to 6 squared. So m squared plus 5m is equal to 36. M squared, I'm going to solve for quadratic now. M squared plus 5m minus 36 is equal to 0. Are there two numbers that multiply to 36 but n add to 5? That would be 9 and 4. Right? So positive 9 and negative 4. M. So m will equal to 4 or negative 9. Well, which one can it be? Because we're dealing with a physical length here, we cannot have negative length. The only one that would make sense is m is equal to 4. And that's it.